Something is wrong with this black hole. Not because it's huge. Black holes are huge all the time. It's wrong because James Webb may have found one sitting between two ancient galaxies, not in the center of either, like it showed up early in the wrong place. And once you see that, everything we know about black holes starts falling apart. Black holes were supposed to make sense. For decades, black holes felt terrifying but organized. You had stellar mass black holes, the kind you get when a very massive star runs out of fuel, its core collapses, and gravity just keeps winning until not even light can get back out. Those are the black holes that come from stellar death, usually a few times the mass of the sun, maybe more, but still tied to the life and death of one star. Then way above them, you had the supermassive black holes, the ones sitting in the centers of galaxies millions or billions of times the sun's mass. That the Milky Way has one, Andromeda has one. Every galaxy we've checked closely enough seems to have one in the middle. That was the old map. Smallish dead star black holes, giant galaxy core black holes, end of story. The problem is the universe started scribbling all over that map. Astronomers began finding black holes in the awkward middle, around 30, 40, 50, 100 solar masses, objects that don't fit neatly into the standard stellar evolution story. If a normal star dies, you don't expect that kind of outcome so cleanly. Then came merger detections, so massive they started falling into what people call the mass gap, a range where current models say these black holes shouldn't really be showing up like this, add in spins pushing close to theoretical limits, and suddenly you're not just tweaking the old story, you're staring at a formation problem. Maybe some black holes build themselves through repeated mergers. Maybe dense star clusters are cooking them up. Maybe there's some separate birth channel we still don't understand, but the point is the neat two-box system is gone. And that matters because once the categories start breaking, every new black hole discovery gets heavier. It's no longer just, wow, cool space object. It becomes, wait, is this thing exposing a gap in how we think black holes are born at all? That's why this new black hole hits differently. Because it doesn't just look weird. It lands right on top of a problem astronomers were already struggling with. And to understand why, you have to go back to the early universe, where things get way more unhinged. The universe started making giant black holes way too early. Here's the part that already had astronomers stressed before this new object even showed up. James Webb has been seeing galaxies with supermassive black holes just 500 million years after the Big Bang. That is absurdly early, cosmic blink of an eye early. The usual idea was that you start with a stellar black hole, then it feeds, merges, grows, and eventually becomes something huge. But when Webb started finding these giant black holes that early, a lot of scientists looked at the timeline and went, yeah, this does not feel comfortable. Because for a stellar black hole to grow that fast, it would have to eat matter at rates that push right up against, or maybe past, what we thought should be possible. Some researchers think that can happen, others are skeptical. Either way, it means the old slow growth story isn't enough on its own. That's where the alternative ideas get spicy. One option is direct collapse, where instead of waiting for stars to live and die, a huge gas cloud in the early universe collapses straight into a black hole under the right conditions. Another is the primordial black hole idea, which goes even further back. In the first second after the Big Bang, the universe was an insanely hot, dense particle soup, not perfectly smooth, with some patches denser than others. In those especially dense regions, matter may have collapsed directly into black holes before stars even existed. No stellar phase, no supernova. Just raw early universe density, making black holes from scratch. That idea has been around since 1966, and if it happened, some primordial black holes could have started huge, even around 100,000 times the sun's mass, which would make them perfect seeds for the giant monsters we see later. And now you can feel the setup. Astronomers already had a mystery. Black holes were appearing too early, too big, and in some cases in sizes that didn't fit the old rules. So when James Webb spotted something even stranger, it didn't land in a vacuum. It landed in the middle of an existing black hole identity crisis. Because this was not just another ancient galaxy with a giant black hole in its center. That would have been weird enough. This was something else. James Webb may have found the black hole that shouldn't be there. In July 2025, NASA reported that James Webb had seen two early disk galaxies that appear to be in the process of crashing into each other. That's already a fun start. Ancient galaxies smashing together is never boring, but the truly weird part was not the collision, it was what Webb saw between them. Sitting there, not in the center of either galaxy, was a supermassive black hole. Not a black hole at the center of Galaxy 1, not a black hole at the center of Galaxy 2, a third one just there between them. And it gets even stranger because the two galaxies seem to have their own supermassive black holes as well. So you're left with this completely uncomfortable picture of a giant black hole that does not obviously belong to either galaxy and was not explained as something simply flung out of one of them. That's why this discovery hits so hard. It feels misplaced. It feels like finding a shark in the middle of a highway and being told, no, the ocean is over there. The team behind the discovery proposed that it may have formed in situ through the direct collapse of a gas cloud. That phrase matters. In situ means right there, basically formed on site, not born in a normal star, not grown slowly in the nice familiar way, but collapsed directly under the right conditions. And if that's true, then this black hole is not just another data point. It's evidence that the early universe may have been able to make giant black holes in a way we don't normally picture, almost like it could just skip steps when conditions got extreme enough. QS01, a supermassive black hole found in a surprisingly small galaxy with incredibly low heavy element content, less than 1% of the oxygen seen in the Milky Way. That matters because heavy elements usually build up after generations of stars live and die. So when you find a galaxy that chemically unevolved with very little sign of earlier stellar processing, but it already has a supermassive black hole, you start wondering whether that black hole really came from the normal stellar path at all. It's not a smoking gun, but it pushes in the same direction. It whispers the same thing. This new between the galaxy's black hole is screaming. Maybe some black holes were never ordinary star corpses to begin with. And that's the real reason this object matters. It doesn't just look dramatic in a headline. It attacks the most basic assumption people casually make about black holes, that they begin as stars, grow over time, and sit where they're supposed to sit. This one may have formed directly early and in the middle of galactic chaos, which is already enough to wreck your afternoon. But once you accept that possibility, you start noticing the rest of the black hole universe behaving like it's way more dynamic, way more chaotic, and way less settled than we thought. The rest of the discoveries suddenly feel connected. Take the rogue black hole Hubble may have found in our own galaxy. For years, astronomers suspected there should be isolated black holes wandering the Milky Way because supernovae aren't always symmetrical, and the black hole left behind can get kicked out like a cannonball, but they're brutally hard to detect because a lone black hole doesn't glow unless it's feeding. The only reason this candidate showed up is because it passed in front of a distant background star and gravitational microlensing gave it away. The event lasted about 270 days, way longer than most lensing events. There was no color change to suggest an ordinary foreground star, and Hubble measured the tiny positional shift of the background star by about a milliarc second, precise enough to estimate the object's mass and motion. One team got around 7 solar masses, very black hole looking. Another got a lower range, 1.6 to 4.4 solar masses, which still leaves room for a neutron star. So it's not a perfectly settled case, but whatever it is, it's the first dark stellar remnant found drifting through the galaxy without another star attached. Why bring that up here? Because it reinforces the same theme. Black holes are not always sitting in bright, obvious systems behaving the way our mental picture wants them to behave. Some are hidden, some wander, some may have been kicked loose long ago. The one Hubble tracked is roughly 5,000 light years away in the Carina Sagittarius arm, moving around 100,000 miles per hour. And the discovery implies the nearest isolated stellar mass black hole to Earth might be as close as 80 light years away. That doesn't mean danger. It means black holes are probably more common, more mobile, and more quietly present than the old dramatic picture suggests. Then there's PBCJ 2333.9-2343, the supermassive black hole whose jet seems to have changed direction on giant scales. It looks like a classic radio galaxy with radio lobes extending about 1 million light years, which tells you the jet used to be aimed far away from our line of sight. But close to the core, the inner jet looks blazer-like, pointing almost directly at us within about 6 degrees. So the most likely explanation is that the jet changed orientation sometime between the creation of those old giant radio structures and the present day. Maybe because of a new accretion event, maybe because of a galaxy merger, maybe because of a black hole merger that changed the final spin axis. However it happened, it means even giant active black holes are not frozen statues. They evolve, they restart, they swivel, they have phases. And once you put that next to the new James Webb black hole, the bigger pattern comes into focus. These things are not just giant gravity pits sitting there passively. They have life stories we barely understand. Some may form directly, some may merge into forbidden sizes, some may roam, some may literally change where they point across cosmic time, which leads to the last thing that really drives this home, the fact that our tools for studying black holes are getting weirdly good. We're finally seeing black holes in ways that used to sound impossible. One of the craziest examples is the first detection of light from behind a black hole. And no, that does not mean light escaped from inside the event horizon. What astronomers saw were X-ray bursts from near a supermassive black hole about 800 million light years away, followed by fainter delayed echoes with slightly different colors. That delay was the clue. Some of the light came from the front side of the accretion disk and reached us more directly. Some hit the back side, then bent around the black hole because its gravity warped space-time so hard that the light could still curve into our line of sight. Same basic principle as gravitational lensing, but in a much more extreme environment. The source of those X-rays is violent too. Near the black hole, you've got this spinning soup of hot charged material in the accretion disk, building intense magnetic fields. Those field lines can arc, twist, and snap, kind of like solar flares but way nastier, releasing bursts of X-rays that shine down onto different parts of the disk. As that light reverberates off material moving at different speeds on the front and back sides, it comes back with different red shifts and blue shifts. That's how astronomers could tell they were not just seeing one blob of light. They were seeing geometry, motion, and warped paths around a black hole from a point source 800 million light years away, which is honestly ridiculous in the best way. So if you want the simplest version of what this new black hole means, it's this. Astronomers may have found a giant black hole in the early universe that was not born the normal way, was not sitting where a black hole should be, and may be pointing straight at a deeper truth, that the universe had more than one way to make black holes from the very beginning. And if that's true, then the black holes we thought were the endpoints of stars may only be part of the story. Next time you hear black hole, don't think of one neat category. Picture a family of objects we still haven't fully sorted out. Some born from dead stars, some merged into impossible sizes, some wandering in the dark, and maybe one new giant that formed almost out of nowhere between two galaxies before the universe had really even gotten started. If you enjoyed this video, make sure to subscribe for more insane stories from outer space.